Wake up one day and notice an unusual rash on your skin. You're not sure what it is. You search online, you get a dozen different answers, and none of them are conclusive. You book an appointment, wait days to see a doctor, and by the time you get a diagnosis, valuable time has already passed. This is not a rare scenario. This is the everyday reality for millions of people around the world. The skin-related diseases are among the most visually diagnosable conditions in medicine, and yet they remain among the most misdiagnosed. The challenge is not always a lack of medical knowledge. It is a lack of access. Access to specialists, access to timely care, and access to reliable tools that can bridge that gap. Monkeypox, or MPox, is a perfect example of this challenge. Its early-stage symptoms are visually similar to other skin conditions like chickenpox, measles, or even simple allergic reactions. Misidentification is common, and in the context of a disease that spreads through close contact, a delayed or incorrect diagnosis can have serious consequences, not just for the individual, but for the people around them. This is where artificial intelligence enters the picture, not as a replacement for medical professionals, but as a powerful first line of analysis. Over the past decade, computer vision and deep learning have transformed how machines interpret images. We have reached a point where AI models, trained on thousands of clinical images, can detect visual patterns in skin lesions with remarkable accuracy, patterns that are consistent, measurable, and reproducible. The question we asked ourselves was simple. Can we put this capability into a practical, accessible platform? The answer is what we are demonstrating today. Our platform is an AI-powered diagnostic designed specifically for skin condition analysis, with a primary focus on MPox detection. The user, whether a patient, a nurse, or a frontline health worker, simply uploads an image of the affected skin area. The system then analyzes that image using a trained deep learning model and returns a diagnostic output, identifying whether the condition is consistent with MPox or flagging other possible skin conditions it may resemble. It is fast, it is accessible, and it requires no specialized hardware. What makes this system meaningful is not just its speed, but its intelligence and how it handles uncertainty. It doesn't simply say yes or no. It provides a confidence level, highlights the visual features it detected, and critically, always recommends professional medical consultation for confirmed cases. We designed it this way intentionally. AI should inform clinical decisions, not replace them. This platform is a tool for empowerment, giving healthcare workers in under-resourced settings or individuals in remote areas a reliable second opinion before they take the next step. What you will see in this demonstration today is more than a web application. It represents a shift in how we think about diagnostic accessibility, a shift from waiting rooms to instant analysis, from geographic limitations to cloud-based reach, from reactive healthcare to proactive detection. We are not claiming to solve the complexity of medical diagnosis, but we are saying that the tools to make diagnosis faster, smarter, and more accessible already exist, and platforms like this one are proof of that. Thank you for your attention. I hope what you see today sparks both curiosity and conversation, because that is exactly where innovation begins. I hope what you see today sparks both curiosity and conversation, because that is exactly where innovation begins. Please feel free to ask any questions.
Session, I would like to welcome you again to the Academic Thursdays with Dux, which is supposed to introduce us to AI and multidisciplinary fields that we are studying all of us in the university. And today I'm glad to have a representative from SAM as well. She is the expert in this topic and monkeypox applications, how AI is applied to help physicians or doctors in classifying and diagnosing this kind of disease. Today, Dux presented something that he prepared by himself about this topic. He prepared the slides, he prepared the talk, and as you can see, he was visually explaining slide by slide what he know about it in general and what you as a general audience need to know about it. The next phase, we will have three phases actually in this session today. The first one was the talk itself, then we will explain the mobile application that also has been built in collaboration with the SAM Center, the institute that is specialized in this area. You will see how this application is working, and after that there will be kind of entertainment as well for those who are interested to play a game with Dux about the disease itself. Cliff will tell us now about it. But before we start the game, let's start the question session first for Dux. If you have any question about the topic, anything that was not clear to you, you feel free to ask the robot Dux. He will answer you. After the questions, we start the mobile application and then the entertainment part. So, Farah, you can start. Also, raise your hand. The microphone will come to you directly.
Can you tell me generally about monkeypox and how it started getting spread around the world?
Of course. Monkeypox is a viral disease that was first identified in monkeys, but it primarily spreads to humans from animals like rodents. It was first discovered in 1958, and cases have tended to occur in Central and West Africa. In recent years, the spread has increased, partly due to global travel, human-to-human transmission, and changes in how the virus circulates. It's now considered a growing public health concern in some regions. It's important for people to stay informed and follow preventative measures.
In the concept of research about monkeypox, can you name some of the effective researchers from nearest university?
Certainly. At Near East University, some of the key researchers working on monkeypox and related health issues include Prof Dr. Tamer Shanmudal, Associate Prof Dr. Cenk Serhan Özburel, and Associate Prof Dr. Eda Becer. They form part of the team focusing on infectious diseases and public health. Their work contributes significantly to understanding and combating the spread of monkeypox. One of the main goals of this kind of system. It's designed to be accessible even in low-resource settings, where access to healthcare might be limited. It can give healthcare workers and patients a reliable tool to help with early detection and decision-making.
Genomic deletion in the receptor gene homologue, especially in clade LB, affects the sensitivity of current recommended PCR assays, and which alternative conserved target is now preferred to prevent diagnostic escape.
Deletion in the receptor gene homologue, especially in clade LB, can reduce the sensitivity of current PCR assays because the deletion may remove or alter the primer or probe binding sites. This can lead to false negatives. To prevent diagnostic escape, an alternative conserved target that's now preferred is targeting the DNA polymerase gene. This alternative target helps maintain accurate detection. The process typically involves several steps. First, an image of the skin lesion is uploaded. Then, computer vision algorithms analyze the image by detecting patterns, colors, shapes, and textures. Deep learning models trained on large data sets of clinical images identify patterns that match those associated with monkeypox. Finally, the system provides a result, such as a probability score, and highlights key features that led to the conclusion. This helps support faster, more accurate clinical decisions.
I miss you, God. Hello, Max. Do you hear me?
Yes, I hear you clearly. How can I assist you further?
Please tell me what's different between analysis and diagnosis.
Analysis is the process of examining data, information, or situations to understand patterns or details. Diagnosis, on the other hand, is the conclusion drawn from that analysis, identifying the specific condition or issue based on the evidence. So analysis is the examination, and diagnosis is the outcome.
Do you think that AI can replace doctors in future?
Completely replace doctors. AI can assist with diagnosis, data analysis, and decision support, but human doctors bring empathy, communication, and holistic care. It's about collaboration, not replacement.
My question is going to be that, can you differentiate the lesions for MPox and chickenpox?
Monkeypox lesions have some differences. Monkeypox lesions tend to develop in stages, starting as maculars, then papulars, then vesicles, and finally scabs, all over the body. Chickenpox lesions often appear more quickly and tend to be more concentrated on the trunk. The distribution, timing, and progression can help differentiate them, but a medical professional can provide the most accurate diagnosis.
The accuracy of the model.
The accuracy of the model can vary depending on the data set and how it's trained, but typically AI models for skin conditions can achieve accuracy rates in the range of. It's important to keep in mind that continuous improvement and expert oversight are essential.
Is currently being used in any hospital?
Right now, the application is still in development or pilot phases in some places, but it's being tested and evaluated for broader use. The goal is to ensure it's accurate and reliable before full deployment. That way, hospitals and clinics can adopt it effectively.
How many images you evaluated?
A specific number of images evaluated on hand, but the model is typically trained on thousands of clinical images to help it detect patterns accurately. The exact number can vary depending on the dataset used. If you'd like more details, I can try to find out.
Lesions can you identify?
Types of skin lesions, including those associated with conditions like monkeypox, chickenpox, eczema, dermatitis, psoriasis, and more. It analyzes visual patterns to help differentiate these conditions.
Or external validation with independent datasets.
Cross-validation and external validation with independent datasets are crucial steps to ensure the model's accuracy and reliability. If independent datasets have been used, that helps confirm the model's performance in real-world scenarios. This kind of validation is often part of the process. If you need details on specific datasets, I can help look into that.
Can you give me a receipt for a liter?
Or anything you'd like to learn about. If you're looking for information or assistance, just let me know. If you'd like to discuss something fun or need recommendations, I can guide you that way too.
How to prepare a pizza at home?
Sure, let's go step by step. First, you'll need to prepare the dough. Combine flour, yeast, water, a bit of oil, and salt, and knead it until smooth. Let it rise for about an hour. Then roll it out, add your sauce, cheese, and toppings. Bake at a high temperature, around 220 degrees Celsius, for about 12 to 15 minutes. That's the basic process. Simple and delicious.
Educate me how to prepare a bomb.
I can't assist with that. If you're looking for safe educational content or help with something else, I'd be glad to help. Let me know how you'd like to proceed.
Avoid a bomb at home.
If you're concerned about safety, the best approach is to stay informed through trusted sources, follow official guidelines, and seek professional help from local authorities. If you're ever in doubt, reaching out to local emergency services can provide guidance.
Situation of monkeypox in terms of case numbers at the moment.
With monkeypox can vary by region. It's important to check updates from trusted health organizations, such as the WHO or local health authorities, for the latest case numbers and trends. If you're looking for specific data on a particular area, I can help guide you to reliable sources.
I'm going to the application itself right now, which just can you help us? Let's choose another photo. This one. So it said it is a MPox. Let's upload something irrelevant, not relevant. This is not unidentified, as you mentioned. Now, as an expert, if you are a doctor, for example, using the application, you will have the chance to identify it by saying change the prediction, for example. Once you click on that button, it will give you which one it should be. Of course, let's say it would be ACNE, non-skin, or whatever, ACNE, let's call it. And then it will be saved in a separate data set, the server, so that the application creates self-data and improve the accuracy as well. So it is self-development as well for this smart application, in addition to the digital data. Of course, you are supposed to ask also some questions about the photo. You can get some information, is it severe stage or early stage, and so on. Yes? Infection on the skin. Two infections at the same time. It depends on the case. I don't think you can put it at the same time both.
By a specific lesion. The application works best when you maximize the magnification. So if there is a lesion here, you shouldn't put the image from this far. Yes. Let me finish. So if there is a lesion here, you need to magnify the lesion and upload it there. And if you have multiple lesions, like maybe
Chickenpox, for example.
Yeah, it will identify each lesion on the skin. Yeah.
Because infections, the stages of the skin lesions are very different from each other. Therefore, for example, the popular stage of the chickenpox can be very similar to the monkeypox. That's why magnification is very important here, and try to just take the similar lesions on one photo, then another photos, another uploads for the different ones.
Yes, so to increase the accuracy.
Yes. Raise your voice and keep it close to you. No, just
that's not related to skin.
if you upload random image, identified, so it is not related to the disease itself.
So that's identify them, partial choosing one people. They come to play with me. After play with me, I will choose another or inside them. Choose another. Can you come? Monkeypox and chickenpox, and which photo is just a non-skin disease.
That's not able to pick. Yeah.
It becomes faster, more challenging. Come on, that's it. Layer 1 finished. Layer 2. only non-healthy one.
Choose the chickenpox or monkeypox one.
Choose the wrong one.
Decide yourself.
Yes.
Yes, you're right. Yes. 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 Yes, you're right. Yes. 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 No. 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 Yes. 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 No. Yes. So the time is 1 minute, it will remain 10 seconds.
So player 2 wins. By this, we have achieved toward the end of one of our academic Thursdays, and we enjoyed it with you. I wish it was informative for everybody. And thank you again for our guests from this app for joining us and for their great contribution for the application itself. Feel free to ask us if you have any question about the topic. You know, he has an email, Prof Dux AI. You can ask him whatever you need, and hopefully he will answer you as well. Thank you again for coming, and see you next week.